Okay, we're going to do the oblique cone, drawing number 10. These are actually fairly easy to do. Oblique just means sloping or slanting. So just coming off the some plate development notes here. Oblique, not parallel nor at right angle, so it's slanting. Okay, don't get that confused with obtuse. So go through the PowerPoint and look to see what your different cones are. An acute cone would be less than 90 here. So this is less than 90. A right cone, this would be 90. So this is known as acute. This would be known as right. And the obtuse is when this angle is more than 90. This is obtuse. So those are just your three different, they're almost triangles really, but they go back to the cone as well. So have a look at your notes. Just get familiar with your terms. Also look at the PowerPoint. There's lots of good information in there as well. The oblique one is always kind of fun. Here's I printed the pattern out, rolled it up, taped it, and it got a little squished, but this is kind of it here. We get into the next one, we'll start joining them together. We'll miter them, so we'll truncate the top. Top on this one is truncated, I just didn't cut it off. So we'll look at these ones here later when we're mitering them. But for this one here, the hardest part for this one is just trying to get the orientation from here, and then the flip out on the bottom, there's your top view. So looking down. So trying to get these element lines on here and trying to get some true lengths is what we're trying to do. You could do triangulation on this, but we're going to do radial line. Radial line is the faster method to do this cone here. Radial line is always faster than triangulation. We'll do triangulation with just our regular cones next year, but not always necessary. So generally when you do something triangulation, it's eccentric. The top has to be off center than the bottom. So this one here is actually still concentric. It still shares the same center line from the apex. It's as soon as the apex, when it doesn't share the bottom, then all of a sudden it's eccentric. Okay, so for this one here, let's just double check. This was 50 here for our radius. So just left a little bit down below, an extra 20, so I came up to 70. It's 100 here for the base. We were 91, 92 to the top. We were offset, off center, 77. And here we had a 61.3. I think that 61.3 came off of 80 coming up the center line. That's kind of where that came from. We're 50 degrees here. You can always double check that with your protractor. You can always put that on there. Double check, make sure you're at 50. It's just what we went with here on this one. So pretty straightforward. So we flipped out the bottom, already got the arc on here. Take the radius here. Let's divide this out. Just so we can get some element lines on here. I did an apex over here, so dropping the apex down below, and we're going to do a top view. So really, I guess what you could do is you could connect these lines, because if you were looking from the top, this is what you would see. So a lot of these lines would go over top of one another, even like this one here. You could draw those on there, but that's what you'd be looking at as if you were looking at it from the top, like this here. Okay? But from those, what we need to do is we need to get a true length of this line. So how do we get a true length of that line? We need to slope it back. So how do we get a true length of that line? We need to kind of go like that with it, or go like that. So stretch it out. So with that, all we're going to do is get true lengths. So we're going to take this here. We can number these here after, and we're just going to bring these up to there. Okay, and we'll get true lengths from the apex coming down here after. So we're just bringing that up to the front view. This is always the hardest part to visualize. A lot of this stuff is hard to visualize unless you make the part, and even when you do make the part, even when you do flip it around, a lot of people still have a hard time visualizing. Like for number 4 example, this center line here is looking at it straight this way. So if you were looking at it straight that way, that would be the length. Well, obviously it's longer than that for the true length here. So how much longer? Well, this is the offset, and this is the height here. So if I extended it out to here, that would then become the true length of this line. So if I ended up taking this here and bringing it out to here. So really it's just bringing this back. So if I took this from here, really I'm just bringing it back. Okay, that's the hardest part to always visualize here with that. Once you see that, this becomes a little clearer. There's another funny thing coming up here as well that we're concerned about, which is a little different than the other cones that we have been doing. We'll see that there in just a minute there as we start to do the pattern. Okay, so again, we can number these. 1, 2, 3, 4, 5, 6, 7. And we're really ready for our pattern, so this could be pretty quick here. So what we're going to do is we're going to come off our apex, and we're going to do, this is a true length already for 1 and 7. So those are, if you were looking straight at it this way, those are not sloping away or towards us, so those are good. But 2 here, 3, 4, 5, and 6 will be coming off of here. So let's go ahead and do that. Hopefully I don't need my extension, which I don't. Let's just go all the way up to the, something happened there with my compass. Not sure what. Something clicked there. There we go. Probably don't need the top anyway. Jump the gear, I think. Okay, 6. Bring all these up here. All the way to the top. I'll have to do the top of the cone as well. I'll do that after. Okay. Okay, so let's just do a little bit of math here. So we got 50, we got 100. So we got 100 times the pi. That 314. And let's divide that into 12, because I think we're going to do a full pattern here. No, we're going to do half a pattern. So we'll divide this into half. So divide by 2. 57. And we'll divide that into 6, just to get the arc length from here to here. 26.18. Okay. Okay, so basically we can start stepping off here. So from this one here, we're not going to step off like our baseline like we did the other ones, because our cut is going to be somewhere different. Our cut line needs to be the circumference of 314. So if we measured along here and cut somewhere else, it's not going to work. So from line 7 to line 6, we're going to be 26 there. Basically 26 and a little bit. So let's set our dividers at that. And what we're going to do is we're going to be stepping off. So we're going to go from 7 to 6, and we're going to go from 6 to 5. So this is a straight dimension, so it could be a little bit off by the time we get to the top. So it's one of those things you kind of have to correct at the end if you have to. Okay, so this is one of those things where 157, if you took your flexible ruler, let's see if I can, I need one of those snakes with the rulers on them. 157-ish, so that looks pretty close to there. So that's just a quick double check on that one. So that'll be the cut line for the bottom. So and that's where that 157 comes through. So it's not going to work coming along the baseline. I've got a bit of a double line on the outside here. Let's just get rid of that. Okay. So we got to go up to the top as well. So before we do the top, let's just go ahead and put our element lines on here. We're just going to do a half pattern with this one. Then we don't need to step off for the top because we've already got our element lines. All we're going to need is a X marks the spot. Okay, so we do need our true lengths coming through this truncated part here. So let's go ahead. We're going to get a few lines on here, I know. Maybe I can use my blue pen. For these true length lines. Four, just because our center lines, it kind of looks like we got two center lines with 4. Just making sure we have a difference with those. 1 and 7 are still going to be the same true lengths. Okay, so for this one here, let's just, well, this one here we want 7, 6, 5, 4, 3, 2, 1. So we need to bring 1 over, or we can start on 6, I guess. So 7 will be right here. So maybe we'll start on 6 and we'll just go that way. So off the apex, on this blue line where the blue line crosses the truncated here at the top. Set that, go over to number 6. Here's number 6. And you're going to go to number 5. Just a little bit shorter. Go to 4. Again, it's the blue line, not the center line. 3, 2, and 1. Okay, now the fun part here with the snake. Again, just using the snake. So the raised edge is for an ink pen, so it's an ink edge on this one. The pencil is on the lower edge here, because we don't have to worry about smudging. Let's go ahead with this here. So basically where that crosses the line. Not too bad here. And it kicks down at the end there. This is just a little bit off. Need more fingers. Okay, I think I got the whole thing. That was an easy one. Okay, this one here is a little smaller. Still going to kick at the end. A little tighter there. Not sure if I'm going to get that in one go. No, I don't think so. I'm going to get it in one go there. That's pretty close there. I'm just trying to swoop back up over here. French curves work sometimes, but not too bad. There we go. Okay. That's basically it. We just got to label this up. Number 4 will be our center line. Put our name on here. 8. Again, just coming off the sheet here. So you're just looking at this. I just work my way through the sheet. This one here is the oblique cone. Number 10. This is a half pattern. Forming direction. So we would have this is actually still on the bottom here, a 100. So form to 100. Diameter. So you can still use a round pattern for that and check that as you're bending. That'll work just fine. What else we got here? I guess we got a sheared edge here. We got a shear edge here. Burnt edge here. Burnt edge there. Quarter marks, I guess. We can go here and here on center. Our ends are quarter marks. Those would be punched through on the plate anyway. Some people like to punch the hole outside when they burn. And I think that's about it. There we go. Drawing 10, the oblique cone.